Hello and welcome to Maths with Jacob. This lesson will focus on differentiation part 5. A special puzzle to warm up the brain cells is on the next slide. The answer will be given at the end. Enjoy. What is the meaning of the following? Good luck with it and see how you go. Finding the gradient by differentiation. As we mentioned in an earlier video, differentiation allows us to find the gradient of a curve at any given point. Before we do that, let us see how using differentiation allows us to find the gradient of two types of lines that we have already seen on numerous occasions. On the very basic number plane to the left, I have drawn the line y equals 3. That's the red line, this one here. We already know that the gradient of this line is 0 because it is flat. Now, let us find the gradient by differentiation. So if the equation of the line is y equals 3, therefore dy dx equals 0, because we've already seen that dy dx of a constant is 0. Dy dx is the gradient. So that's how we also find the gradient through differentiation. Now let us look at y equals 2x minus 2. So here is the green line, which is y equals 2x minus 2. This is in the form y equals mx plus b, so m equals 2. From our earlier work we know that if an equation is in that form, then here is the gradient, m equals 2. But dy dx equals 2. So if we differentiate this function, dy dx equals 2, and this is the gradient of the green line. Example 1. Find the gradient of the function y equals x squared minus 3x plus 7 at the point 411. Using function notation we have function x equals x squared minus 3x plus 7, function dash x equals 2x minus 3. Remember in an earlier video, this was one of the acceptable ways of signifying gradient. So function x equals 2x minus 3, function dash x equals 2x minus 3. Therefore function dash 4 equals 2 times 4 minus 3, which is 8 minus 3, which is 5. So the gradient at the point 411 of that function is 5. The above example can ask for the gradient in a slightly different manner. Example 2. If function x equals 3x squared plus 4x minus 8, find function dash 2. So, there is function x here. There it is. So, function dash x is 6x plus 4. Therefore function dash 2 is 6 times 2 plus 4, which is 12 plus 4, which is 16. So that's the gradient. Example 3. Find the gradient of the function y equals x squared minus 2x minus 3, where it cuts the positive x-axis. So after factoring, the above parabola can be written as y equals x minus 3, x plus 1. So we've seen many times how to factorize that expression. There it is there. Now, it cuts the positive x-axis at 3, 0. See, we know from here that it cuts the positive x-axis at 3, 0. So, if function x equals x squared minus 2x minus 3, function dash x is 2x minus 2. Substitute x equals 3 in here. 2 3s are 6, 6 minus 2 is 4. So function dash 3 is 4. Example 4. This is a little bit involved, but it's quite straightforward, so let's see how we go. Find the equation of the tangent to the parabola y equals x squared minus 5x plus 6 at the point 4, 2. At the point 4, 2, the tangent touches the parabola at this point only. we already have the point through which the tangent passes. we now need to find its gradient. So we have to find the gradient of the tangent. Then we can use the point gradient formula to find the equation of the tangent. So we're given that function x equals x squared minus 5x plus 6. Function dashed x is 2x minus 5. So function dashed 4 equals 2 times 4 minus 5. So function dashed 4 is 3. So the gradient of the tangent is 3. Now, we use the point gradient formula. y1 minus y1 equals m outside of x minus x1. x1, y1 is 4, 2. M is 3. We substitute those values into the equation. We simplify to get to that line. So the equation of the tangent is y equals 3x minus 10. And you can see that the gradient there is 3. Here's a quick quiz to help you. Please check through the video at any time. The answer to the puzzle. What is the meaning of the following? Breaking a custom. Very interesting one. Here are the answers to the quick quiz, and the video is at your disposal.